So the next portion of our transformations that we'll look at is reflection. Reflection is a flip, so it's like that mirror image that you see, over a line called the line of reflection. Each point and its image are the same distance from the line of reflection. A reflection is also an example of a rigid motion. Okay, there are three lines of reflection, of common lines that we see. We'll see problems where we're asked to reflect over the x-axis or the y-axis. Okay, there are vertical and horizontal lines in the form of x equaling a number, and that's our horizontal, or y equaling a number, and that's our horizontal. We can also see diagonal lines. For example, it would be y equals x and y equals negative x. I left my reference sheet at school, so I went ahead and just jotted down the reflection rules here, but you have that colored sheet, or you should. If not, please get an extra copy in the classroom tomorrow. Okay, so here we go, looking at reflecting in the x-axis and the y-axis. Okay, so that's our first line of reflection, is looking at the x and y-axis. And I'm going to take my time with this video, so feel free to pause, rewind, speed it up just a little bit. Please really fight that urge to want to just get to the end and copy these notes so you don't miss out on anything. Okay, so we are being asked to graph and label each figure and its image under a reflection in the given line. Okay, so just like our translations, we want to graph our pre-image. So -4, 2 is A. Okay, remember positives to the right, negatives to the left, positive up, negative down. Don't forget to label each point. 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. There's B. And point C is at 5, 1. 1, 2, 3, 4, 5, 1. Okay, and now I'm going to use my straight edge. You can use your ID, you can use your protractor, your ruler. I'm using my daughter's Barbie card here. Just be as precise as you really can. Take pride in your diagrams. Okay, so there's my pre-image. So I want to look at the rule, just like we looked at the rule in translations, and they're asking us on this one to flip over the x-axis. So I'm going to go to my rules over here, the x-axis. What they're wanting me to do is take my original point, and we will simply be changing the y values to their opposite. Remember, negative is opposite. So for my A, it would be -4, 2, but since I want A prime, I will simply change my y value to a negative. 4, 7 for B, changing that 7 to a negative. And 5, 1 for C, again changing the y value to a negative. Okay, now it's time to graph it. So -4, -2, and that is A prime. 4, -7, and that is B prime. 5, -1, C prime. Go ahead and highlight, let me get a different color, my line of reflection here. So you can see that each point is the same distance from that line of reflection. So see, I climbed up one for the pre-image, now I've climbed down one for the image. Okay, so you'll see they should line up here, and it's always good to kind of take a second to look, make sure everything looks straight, it's all the same size. Remember, with rigid motion, you are, like our translations, we were sliding them, but we were not changing the shape or the size of that image. Well, here we are reflecting, so we're flipping it over, but we're not changing the shape or size of our image. Okay. Let's try the next one. Okay, we're graphing a rectangle here. My pre-image, 1, 2. So remember, positive, negative, positive, negative. So I'm going to start the origin. I'm going to walk 1, climb 2. That's point P. Walk 2, climb 5. It's Q. Go back to the origin. 8, 3. That's R. And 7, 0. That's S. Okay, using my straight edge again. I do encourage to use colored pencils, or if you want to use pens so you have different colors so you can see your pre-image and your image, erasable pens. So fingers crossed I don't make a silly mistake because I forgot my whiteout. Okay, so this time we're reflecting across the y-axis. The y-axis. Okay, so the rule for the y-axis, looking at my reference over here, is negative xy. You know what I'm going to do? I'm going to go ahead and start writing those. The more I write them, the more I'm going to have those memorized. So this time I'm changing my x values to their opposites. So for p prime, it would be negative 1, 2, changing the sign from positive 1 to negative 1. Q would become negative 2, 5. R, negative 8, 3. And S is negative 7, 0. Not too bad. Now we graph them. So negative 1, 2 would be P prime. Negative 2, 5 is Q prime. Negative 8, 3 is R prime. Negative 7, 0, S prime. Trusting those rules, it's like trusting a recipe. Follow it to the T, you should get something delicious, right? Look at that. Beautiful. Reflected over the y-axis. Your y-axis is right here, and you'll notice all of your points are the same distance from that y-axis. 1 to the right, 1 to the left, 2 to the right, 2 to the left, and so forth. Okay. Moving on. This is being reflected over the y-axis. I encourage you to pause the video, try this on your own, see how you do, and then start it up again and watch me solve it. So, negative 5, negative 2, negative 2, F, negative 2, negative 2, G, 0, negative 6, and negative 8, negative 6. Now applying my rule, reflecting over the y-axis means I change my x's to the opposite sides. So if it's negative, it becomes a positive 5 now. My y stays a negative 2. Positive 2, negative 2. 0, negative 6. 0 is neither positive or negative. It's just, it holds that place in between. So if you have a 0, you don't need to worry about changing the sign. And then positive 8, negative 6. Okay, and then we start graphing. F prime, H prime, I prime, and G prime. So you're going to notice if it touches the axis and it's being reflected over the axis, your point continues or is repeated there. Your other shape also stays on the axis it's being reflected over. Alright, so it's being reflected over the y-axis. There's that line of reflection right there. Okay. So, I hope you did good on that. Let's try the next one. Go ahead and pause the video, try this number 4, and then start it up again and see how you did. Okay, this time we're reflecting over the x-axis, so that means I'm changing my y's to the opposite. Negative 2, negative 4. W. 1, negative 2. Oh, I didn't change the colors of my pen, did I? Got me a rhombus here. Rhombuses have equal sides. It's like a square that's been slanted. Still fits in the family of a quadrilateral and a parallelogram. There we go, my camera's having trouble focusing. So that's my pre-image. Now I'm going to apply the rules of reflecting over the x-axis where I change my y values. So negative 2, positive 4, 1, positive 2, 4, positive 4, 1, positive 6. So it's being flipped upward. Okay, so negative 2, 4, it's W prime. 4, 1, 2, y prime, 1, 2, x prime, 1, 6, and z prime. It looks like it's going to be another rhombus. Remember, it should not change shape or size on reflection. Continuing on, now we are going to look at reflection over vertical and horizontal lines that are not necessarily our x and y axis, okay? So we, again, want to identify the rule that they're asking us to do, and they're asking us to reflect over where x equals 4. Now, if you remember where we have x equaling a number, that is an undefined slope. So So there's no y in our equation, so our line should not slant over and touch the y-axis at all. There we go. 1, 2, 3, 4. Put a little point there just so I can see a different color just so it sticks out a little bit. Okay, so there's my line of reflection. I might actually highlight it too, just because the lighting in here is kind of hard for me to see. There we go. Okay, so again, I'm going to still starting from the origin here. 1, negative 1. There's J. 2, positive 3. There's K. And 1, 2, 3, negative 2. Looks like a scalene triangle here. Using my handy dandy straight edge. Oh, I forgot to label that last one. I always do that. L. Okay. So this is a little bit different because we're wanting to reflect over the line of x. This as if it was my y-axis, and we know with our y-axis that we only end up changing our x values. So I'm going to use this. I'm going to count from here now for my image to my pre-image. So it went to the left 2, so I'm going to now go to the right 2, and there's K prime. Okay, so left 1, now I'm going to go right to the left, so I'm going to go 1, 2, 3 to the right, and there's J prime. Okay, when I write my ordered pair, oh, I guess I should go ahead and connect that and make it a triangle. So what I was getting a little bit excited to explain here is when I write my ordered pairs, I'm still going to walk and climb from my origin to get those points, okay? So for J prime, from the origin, I'm going to walk 7, climb down 1. So 7, negative 1. For L, again, go back to your origin, and it's just like you've always done from L. It's easier to draw my diagram, then find my ordered pair, and on the translations, it was much easier to write the ordered pair and then plot the point. But you find what works best for you here. Again, from the origin, walk to the right 6, climb up 3. And there are my ordered pairs for my reflected image over the line x equals 4. So you pause the video and try this one on your own. Remember, this is your x-axis, this is your y-axis. So your line of reflection is going to be at x equals negative 1. There's no y in my equation, so do not slant that line. It has no slope. It's an undefined slope, I should say. Okay. There is your line of reflection. Go ahead and try that, and then when you get back to class with me, we will go over these and see how you did. Okay. All right, moving on to equation. That is a horizontal line with a 0 slope. Okay. So I'm going to, here's my x-axis, here's my y-axis. I'm going to walk up 2 on my y-axis. It is a horizontal line. Again, I'm going to highlight this just so I can see it better. My lighting in here is not very good. Alrighty, so let's get our pre-image graphed here. Going back to my origin, just going to plot it my points like normal, -4, -4. And that is C, -2, 0, D, and 4, -3, F. So we've got a nice little parallelogram forming here using my straight edge. Definition of a parallelogram is a quadrilateral with two sets of parallel sides. And those opposite sides are also congruent. Okay, there it is. Okay, so now reflecting over the line of x equals 2. So I'm just going to start here with C. So C, I went down 1, 2, 3, 4, 5, 6 from this line right here. So now I'm going to go opposite, up 6. 1, 2, 3, 4, 5, 6. And there is C prime. D, from my line of reflection, I would go down 1, 2. So the opposite would be climb x values. We're only changing the y values. E went down 1, so climb, woo, yep, up 1. I hesitated for a second. Sometimes that happens to us. Math kind of intimidates us a little bit, makes us question ourselves. 1, 2, 3, 4, 5 down. So now I'm going to go 1, 2, 3, 4, 5 up. And there's F prime. Okay. Now remember, this is a mirror image, so it's going to just kind of look, it's just going to be flipped. It's not going to change shape or size. Just like looking in a mirror. It's still you, just flipped image of you. Looks pretty good. Okay, now again, when I write my ordered pair, this is a common misconception I see, is that we want to walk and climb from our line of reflection. No, you still go to your origin to get your ordered pairs. Okay, so for C prime, I'm going to walk to the left 4 and climb up 8. So -4, 8. So again, you'll see you did not change your x values, only your y values. Okay, and then D prime would be to the left 2. No, I did that wrong. Where is it? Okay, to the left. Oh my goodness, I'm counting. Look, I went to the origin. I'm so silly. Okay, from my line of reflection, I climbed down 2. Yeah, so then up 2. That was right. Okay, oh, I'm getting tired, you guys. So -2, +4. All these little squares eventually get to me and they start looking jumbled. Okay, from my origin, I'm going to walk 6, climb 3. So it's hard to see that x-axis for me right now, so I'm having to like be very careful. This is my origin, okay? So you can notice I'm struggling here. So from my origin, I would walk 1, 2, 3, 4 to the right, and then up 1, 2, 3, 4, 5, 6, 7. So 4, 7. Okay, go ahead and try the next one. It's reflected over a horizontal line at -5 on the y-axis. So 1, 2, 3, 4, 5. Go ahead and draw that for you. Try this one on your own, and then we will go over that in class. When you get caught up to this, bring it to me, and we will go over it and see how you did, okay? And you know, it might help if I like lightly color my origin too. So when I'm trying to find those ordered pairs, I know I should be starting there. But give it a try. Let's see how you do. Okay, for our next reflection, we are going to be looking at reflecting in the lines where y equals x and y equals negative x. Okay, and there are some rules on this one. So let me go back to the front of my page. So when y equals x, when I'm going to take my original, my pre-image, and I'm going to flip my x and y. So I'm going to just write that here. When y equals x, then I take my pre-image and I flip my x and y, my horizontal and my vertical. And then if y equals negative x, I flip, but then I also change to the opposite signs. And this is on your reference sheet. Again, I forgot my reference sheet at school, so I just had to copy those down. Okay, so those are the next ones we are going to focus on. So our first example here is looking at reflection over the line y equals x. So I'm just going to trust this formula here, get my pre-image drawn out here where it's a triangle, so -5, -2, and that's x, 3, 1, 2, 3, 4, y, and -1, 1, there's my z. Okay, so again, I'm going to use these rules here.